Hi, just a little quick review about the geometric distribution. We went kind of fast today, so this is a chance that we can go a little bit slower. You can take your time and you can take a look at, or just take a look and make sure you understand what the geometric distribution is. Okay? The basic difference between binomial and geometric is that the binomial basically says how many successes in n trials. Okay? The geometric asks the question, how many trials until the first, and that's important, the first success. So what we did in class today, looking at batting average, let's suppose our batting average is equal to, let's say, 350. Okay? Don't I wish? In a binomial problem, if x is binomial out of, let's say, 10 at-bats with a probability of success of 0.350, I could say the probability that x is equal to 4. That means what's the probability we will get 4 hits out of 10 at-bats? And for that we can use the binom PDF in the calculator and so on. Binom PDF of 10.350, 4. And we can find out what that is. The geometric question, same probability of success. If y is geometric with a probability of success of 350, now this means what's the probability we will get our first hit on our 4th at-bat? First hit on the 4th at-bat. Okay, that's the basic difference between binomial and geometric, and you have to know that difference. Because in the problem, you're going to have to read the problem and decipher which way to go. Is it number of successes out of n, or is it how many trials until the first success? And to solve this problem with the calculator, you would use geometric PDF 0.354. Why is there no n here? Why is there no 10? Because there is no fixed number of trials for a geometric distribution. It's just how many times will you go to bat before you get the first hit. That's why there's no n. There's no fixed number of trials here. That's the big difference. Okay, so now let me flip the page and let's talk about the differences in the inequalities. For a binomial and a geometric random variable, this means what's the probability of no more than 4 successes out of 10 trials. And let's go ahead and just keep n equals 10 and p equals 350. Okay? So this is a CDF function. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a CDF function. We're looking for these probabilities right here. Probability of no more than 4 successes out of 10 trials. Same idea in the same statement in the geometric is going to look like this. This is the probability of getting the first success on no more than 4 trials. Okay, in other words, we have 4 specific things that could happen. We could get success on the first trial. We could get our first success on the second trial, which means we failed the first time. We could get our first success on the third trial, which means we failed the first 2 times. Or we failed the first 3 times and then got a success. That is how you figure out or how you interpret a geometric probability where y is less than or equal to 4. Okay, now this one doesn't have an analog to what we did in the binomial. Okay, so you can't do this with the geometric and have it really mean anything. Okay? This probability then, should do this in red, this probability is going to be geometric CDF of probability of success and 4. Okay, and the one last note here. Let's suppose you're finding the probability that y is greater than or equal to, let's say, 3. Okay, if you can think about it, what we're looking at here is getting the first success on the third or higher try. The third try or the fourth try or the fifth try. So basically we're looking at the following scenarios. Fail, fail, succeed. Fail, 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 succeed. Fail, 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 succeed, and so on. Like that. And it just goes on forever. Right? We could fail a lot of times before we succeed. That's what makes this probability hard to do, because it goes on forever. There's a calculus way to figure it out, but we're not going to talk about that. We're going to do something a lot easier. Instead of doing the probability of y greater than or equal to 3, we're going to do 1 minus the probability y is less than or equal to 2. Same idea as what we do with the binomial distribution when we look at the other side, only now we can use the geometric CDF to do this. And the calculator speak way to do this would be 1 minus geometric CDF of 0.350 and 2. And that'll find that probability for us. Okay? I hope that clears it up and that helps out. We'll see you tomorrow.